The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to today's webinar looking at strategies and solutions to secure your public cloud assets and workloads. My name is Shona Bradshaw. I'm the Marketing Manager at Bytes Security Partnerships. I'm delighted to be joined today with Andy Condliffe, who's a Checkpoint Cloud Specialist, and to take you through the bulk of today's presentation, looking at how you can secure the assets in the public cloud against emerging and rising threats. So just a little bit of an agenda for today's session. I'll do a very brief Bytes intro. I will keep it brief, as many of you know already, and then set up today's session with a bit of an introduction, talking about why businesses shouldn't be tempted to accept less security in the cloud than on their premises. I'll introduce Andy, who will take you through Checkpoint's Cloud Security Toolkit, a bit of information around current security levels within AWS and AZURE, talk to you through what we are seeing, what they are seeing customers do in terms of preparing a solid cloud defense against advanced threats, and then briefly talk around Checkpoint's VSEC Cloud Protection Solutions and how they can assist in that fight against advanced threats. We'll have a Q&A at the end, we'll wrap up with that. Please do post questions via the questions box on your screens, and I will pose them all to Andy at the end of the session. So a little bit of housekeeping for today. Attendee lines are on mute throughout the presentation, but please do pose those questions to us via the chat or the questions box. I'll be monitoring the questions throughout the session, and I'll definitely post all of them to Andy at the end. In terms of the rules of engagement for today, we won't be talking commercials and pricing on this session. We are going to be keeping the discussions and the chat around the strategy and solutions that are available to protect the cloud. Of course, those conversations are welcome post-webinar via your Bytes account manager. We will have a recording available post-session, and I'll make sure to share that with everyone who attends today so you can review that content and share that insight within your wider business. Lastly, we do have a feedback survey at the end. It's a short 5-question survey. It's just designed to enable us to understand how we can improve the session forward, what was good, what was bad, etc. So if you could take a minute after the session to fill it in, it would be greatly appreciated. So who are Bytes? So Bytes Security Partnerships are the security specialist reseller within the Bytes Technology Group. And what we aim to do, our core aim as a business, is to marry up the agility and insight and personal approach you would expect from a very small specialist partner with the resources and stability and reach and relationships that you would expect from the largest multi-billion group. We're absolutely passionate about the technical expertise we offer and bring to the table around all of the vendor partnerships we work with. We have a fully accredited engineering team to run in-house support for Checkpoint and other technologies. We have a variety of different technical services, including a managed service around firewalling. So what we aim to do is to really plug that gap between the large globally based technology partners and provide you with a partner you can work with in the UK to support you and make sure that technology works for your business. We work right across the security spectrum, from network security, which is what we're essentially talking to you about today in terms of cloud-based firewalling, access and authentication. We work with partners across data security, and increasingly working and speaking with businesses about how they secure their journey to the cloud, and once in the cloud, how they manage and secure those assets within. So what we provide as a business partner to companies is the technical services that goes around all of those solutions and the expertise, from project scoping and planning and market awareness sessions such as today and going on site, strategy development, technology delivery, installation maintenance, and lastly, support 24/7 or business hours as per requirement to make sure that in the event that something goes wrong, you're fully supported and get back and running as soon as possible. So why are we speaking to businesses about cloud security at the moment? Why are businesses coming to us and asking us about how to secure and augment the in-house security within Amazon, AWS, etc., with specialist third-party solutions? Well, there are inherent limitations in some of the built-in protection available from cloud platforms. Both Microsoft and Amazon have been quite public about the fact that security is a shared responsibility between them as an infrastructure provider and the companies with their specialist security products. There is also limited attack prevention offered from legacy methods such as antivirus, etc. So businesses on-premise have invested heavily in ensuring they have a stronger level of security. However, when moving to the cloud, not every business is actually looking at extending that strong on-premise security to the cloud. At the same time, regardless of where data is hosted, companies are accountable for the security of that data, especially with the impending impact of legislation such as GDPR, which states that regardless of whether your data is hosted on premise or in the cloud, ultimately the data processor is responsible for that data. So what we're doing is speaking to businesses to help them understand the latest solutions available to augment the existing security facets of those cloud platforms, and how they can ensure that they are confident, regardless of where their data and where their assets reside, that they have that strong level of security and it's easily managed internally as well. So that's really why we've invited Checkpoint to talk to you today. We've been a 4-star elite partner of Checkpoint for over 5 years and a top tier partner for 10 years before that. And the reason we work with them is they really are the global leader in network endpoint and next generation threat prevention. They have a sort of very strong story to tell in terms of their relationship with Microsoft and Amazon in developing joint security solutions for the cloud. And Andy himself, our presenter today, is one of the specialist cloud engineers at Checkpoint, so an ideal person to walk you through what Checkpoint are seeing in the cloud and what businesses are actually doing with them to ensure their strong security. So with that in mind, I'm going to pop off audio. I'm going to hand over to Andy and let him take you through some of their insights into cloud security, and I'll pop back on at the end to pose your questions to Andy in an open Q&A. Thank you. Andy, I can see your screen.
I was just going to ask you if you can see my screen. That's good. That's always a good start. Okay, so good morning, everyone. Sorry, you just muted me, Shona. My name's Andy Condliffe. I'm as Shona said, I'm a cloud security engineer for Checkpoint. So I sit in a European overlay team and specialize in our VSEC product range. So why are people moving to the cloud, first of all? So the main reasons are the agility, the speed to react, and the elasticity. So you can quickly deploy environments within hours. Not all our customers are at the kind of automation level where they'll run use tools like Ansible and so on to automatically deploy, but it's that capability is there, and what used to take days or weeks to deploy and build in the traditional data center will now just take minutes within the cloud. So in terms of adoption levels, and also the figures here from people like RDC and Gartner, 80% of enterprises are committed to a cloud strategy by the end of this year. Next year, 40% of IT budgets will be cloud-based. So clearly, lots of organizations are we're seeing this as well, are now moving to the cloud. And yet, interestingly, security is the main inhibitor for cloud adoption. So it's the thing that's slowing people down, and I think probably as well that a lack of understanding in what security is there and how to best protect the environments within the cloud. So first of all, we're going to look at the challenges for the modern data centers. So this applies to public cloud, private cloud. Traditionally, organizations have used the perimeter gateway for protection, but that doesn't give you the security between the applications, the east-west traffic, as it's sometimes called, and that's in reality that's where most of the traffic flows is. I mean, the figures you probably typically around 80% of traffic is internal, as opposed to 20% is out to the internet and back. So again, one of the challenges in protecting data centers, whether that's public cloud or private cloud, is the ability to control that lateral movement of threats. And that's something we've tried to take into account when we've been designing VSEC. The second challenge, and this is very more applicable really to public cloud, is the dynamic nature. So applications are spun up quite quickly. Sometimes VMs are shut down for periods of time to save money. So when the virtual machines and when the apps are first brought up, or when they've been shut down for a while, they're not fully patched. The applications are potentially vulnerable to attack. So having that intelligent level of protection and the ability to provide patching through IPS blocking and prevention is quite critical. I mean, I've deployed Windows machines and Unix machines, and the cloud vendors do a reasonable job of keeping them the images patched and up to date. But then that's not really their job. So with a customer recently, we brought up a Windows machine, and it needed a security roll-up and 2 other patches. But as soon as that machine's brought up and visible, if you haven't got the right protections in place, then obviously that's vulnerable. The third challenge around this is the complexity of the environment. So again, while the private clouds and the public clouds do have levels of security built in and their own levels of protection, they're all different in both how you configure them, how they log, and it's very difficult then to create a consistent security policy across your environment with your traditional infrastructure, private cloud, public cloud. So if you're not careful, you'll end up with very different levels and an inconsistent policy, and the logging and so on in different locations as well. So again, you don't really get that central visibility of what's happening across your whole estate anymore. So I'm just going to go high level across the AWS and Azure, just a high level overview of what they do, how they work, before we go into sort of VSEC and how we work with the products or with the platforms to improve the security. So with AWS, they have 17 regions around the world. And including in the US, they have a specific government cloud region as well, and 6 new regions, which you can see from the green circles, that are coming online fairly shortly. Within each region, and each region is independent, although can be linked to other regions, but each region will have a number of availability zones, and the availability zones will be separate data centers. So within sort of Western Europe, you'll have maybe 3 availability zones, and they're separate physical data centers, which is again is useful to know from a high availability point of view, but also when you're designing your security and how that interacts, because I can't run a cluster, for example, between 2 availability zones, because I've got networks in different physical locations. All these things need to be taken into account when you're designing your infrastructure. So there's a total of 42 availability zones. Each region normally has 3 availability zones. Some have more. And the availability zones are connected by all the cloud vendors with their own infrastructure to give low latency links between the different availability zones and regions, so that you are, whenever you even between regions, you're always using their own infrastructure, so that you'll get, fast response between the different regions and zones. With Azure, they've got 36 regions and 6 additional regions planned. These maps and so on are all available on their relevant websites, and obviously they're updated fairly regularly as they keep adding new zones and new regions all the time. So what Azure does is slightly different. So they have, and this might not be the clearest slide in the world, but what they have is fault domains, which is indicated by the sort of 3 silos here. So fault domain 0, fault domain 1, fault domain 2, and update domains. Now this will be within a single data center, but what this allows you to do is have resilience within a data center. So if I deploy what Azure terms an availability set, so our cluster, for example, would be an availability set. They will make sure that behind the scenes, and this is not something you worry about, you just create an availability set. They'll make sure they're in different fault domains, so different physical servers and racks and power supplies and so on within the data center, but it is still within a physical data center. The update domains are when, obviously, they still need to apply patches, maybe to the underlying hypervisor, for example, and in doing so may from time to time need to reboot those VMs. So again, they make sure that where you have an availability set, it's in a separate fault domain and it's in a separate update domain. So you know, if they're having to patch their environment, you wouldn't lose both halves of both members of your cluster or your web farm at the same time. What they're also doing, which is not, this is only available in, I think, East US 2, yes, East US 2 and Western Europe, is they're now introducing regions availability zones within the region in a similar way to AWS. So these will be guaranteed to be separate data centers. So within each region, they'll start adding availability zones. This is not generally available yet, and as you can see from the slide, not everything is supported today within across the different availability zones. So this is a new feature that they're adding. But they will, what they will give us then is the ability to choose different availability zones, and within each availability zones to create availability sets. So it's a little bit more complex in some ways, but really it gives you more flexibility in deployment as well. So the other thing you need to do when you're actually starting to look at the cloud is understand the different terminologies, and I've included Google Cloud as well, as we run on Google Cloud. So the network is called the VPC in AWS, or a VNet in Azure. In Google Cloud, it's the network or VPC. The compute is an EC2 instance in AWS, Elastic Cloud Compute. For Azure and Google, they just call it a virtual machine. When you create your VPC or your VNet, there'll be an internet gateway object of some kind where the NATing takes place. So you'll create a virtual network, give it an IP range, break it down into subnets, and then you'll route out via one of these gateway objects. And where we're introducing security gateways like VSEC, the outside of the firewall effectively would route out to the internet gateway object. On the inside, you would route to the firewall in a similar way as you would on a physical environment. There isn't really routing as such in the same way. So they tend to use elastic load balancers. AWS is elastic load balancer. For Azure, it gets a little bit confusing because they would use ELB as an external load balancer and ILB as an internal load balancer. External meaning it has public IPs, internal meaning it has private IPs. But load balancers again to load balance traffic across multiple machines, or again you can use them for other things such as using them as NAT devices as well. We can also use auto scaling. So again, one of the deployment methods is to have auto scaling, so we can automatically deploy additional gateways, or in front of if you've got a web farm that's particularly spiky in traffic. So a good example would be retailers now coming up to Black Friday. Their normal traffic is probably going to shoot up to sort of 4 or 5 times their normal level. So they can scale up with the firewalls just to cope with that peak, and obviously the web infrastructure and so on behind. And then when that's over, they can scale down again. So they can just use that elastic resource when it's needed. Authentication services, in identity access management, or in Azure cases, Azure Active Directory. And again, you can sync that with your on-prem Active Directory as well. In terms of access control, they have security groups and network security groups. Google has firewall rules. We'll talk about those in a bit more. And then automation in creating things like clusters where it's a bit more complex. AWS has cloud formation templates. Azure has solution templates, and Google has the deployment manager. And this is the wrong terminology. This isn't actually my slide. So the VPN services, what what we're really talking about is how do you connect in? You've deployed your cloud, how do you connect in? So you can connect in over the internet with a VPN, or you can have a direct connection. So AWS has a direct connect, which is effectively an MPLS link from your site into your AWS environment. Azure has ExpressRoute, does the same. It's an MPLS link into your environment, so you can get a better SLA, obviously, if you've got a dedicated link than just going over the internet. So in terms of when you're deploying, I guess with AWS, one of the key things here is with every VPC will need at least one routing table. Normally, when you've got a gateway in, there's going to be 2 routing tables. But the key thing here is you can't change the routing within that local VPC. So in my slide here, I've got a 10.0.0.0.16. I cannot change that route. So security aside, everything within the VPC can see everything else within the VPC, and you can't change that. So that does create some issues, particularly starting to look at things, trying to introduce segmentation. So one way we can do this is to have an interface in the subnet and then routing on the host to route via that interface address. But that requires a tick in every single subnet, and that doesn't really scale. So small deployments and customers just trying something out, it works, but as you grow to large deployments scale, we can only do, I think, 8 NICs, so you're limited. So it doesn't really work. So what we typically see, and we have knowledge-based articles on this and talking you through how to deploy this, is we'll have multiple VPCs and effectively as a subnet. So in this example here, Spoke 1, for example, could be my web servers, Spoke 2 could be my applications server, Spoke 3 could be my database, and I'll use a VPN to connect it into my transit VPC where I've just got my VSEC gateways, and this way, because it's a VPN, all the traffic will hit the gateway, and we have full control of traffic, and we can do the full deep inspection of all the packets, provide the 0-day protection, and all the things that you would do with your on-premise firewall. If you want to go one step further and start to restrict traffic within the individual space, then you still need to use the security groups within AWS. But what we are going to do fairly soon is that we're about to come up with a trial on this, is allow you to use checkpoint. So you still just have one place to configure your security. And then from your on-premise, again, you can just VPN into your VSEC gateways, and your transit VPs connect just directly in with Direct Connect. And again, we can still, to get to the spokes and where the servers are, the traffic will still have to transit the gate, and you can apply the inspection. And this is very typical. All vendors deploy in a similar model, because it's the only way we can control the traffic flow and force the traffic through the gateways. So again, particularly with AWS, if you're thinking of using AWS, you've got to think of security and how you're going to enforce the security before you start the rest of the, because it's once it's deployed, it's very difficult to refit because of these limits in the control you have over the routing. Azure routing is a lot more flexible. So by default, every subnet will get a system route associated with it. So again, there'll be 2 routes. One for, in my example here, I've got a 192.168.0.0/16 network, and that will be via the local VNet, so the SDN. So again, everything can route to everything, and there'll be an internet rule which points to an internet gateway object. The advantage with Azure, though, is I can create my routes called user-defined routes. So if we look at a simple example, we've got 2 sets. The system routes will allow them to talk directly, and the default route will point to the internet object. But what I can do is create my user-defined routes and redirect them through a virtual appliance. In our case, that would be obviously VSEC. So now we can reroute the traffic, we can protect the traffic between the different subnets, we can protect north-south traffic, and I've actually got a more detailed slide here to sort of go through what it would look like. So in this example here, we've got a gateway, and typically we have the networks that the gateway is connected to are routing networks. We've done a /24 here, but you could make them smaller. And again, the way we're deploying here is the standard way, regardless of the vendor. This is the way people would deploy, which is the user-defined routing. So by default, we've got some servers that are already here, and they're using next hop will be the object, or for machines talking to each other, they'll use the virtual network.
Andy, Andy, sorry to interrupt. Your line's breaking up a bit. I'm just checking that your speaker connection's working, etc. So you're breaking up for every second sentence. We're missing, you're kind of stuttering on the word. It seems like there's a bit of a delay or a lag.
Would it help if I dialed in mobile?
It might do. It might do. If everyone's happy to just pause for a second. I'm just conscious of the fact that the connection isn't good.
Okay, give me a second. I'll dial in on the phone and see if that helps. Just give me a second then.
Apologies for the slight delay, everyone. I just want to make sure the audio is as clear as you need it to be. Well, Andy's taking you through the detailed part of the presentation. He'll just be back on in a second. Okay, I'm hoping everyone can hear me fine. If there are slight audio issues, it doesn't look like it's a mobile issue. What I'll do is I'll just check the connection for the actual webinar and just see if I can improve that so you can hear me clearly. If someone can just drop me a quick note so you can hear me fine.
I'm back on the phone now. Is that better?
I can hear you fine. If yes, I've got a clear from the audience, so I'm going to mute off, leave you to it, and hopefully we won't have to interrupt you again.
That's okay. That's okay. So yeah, back to the Azure routing then. So I've got an example here of I've deployed a VNet. There's some existing servers that are at the moment are going out just through the Azure routing. So the default route points to the internet object. The network itself is routed via the virtual network, so the SDN within Azure. So again, all these machines can see each other. So the first thing I want to do is route those via the VSEC gateway. So I create a user-defined route and put the IP address of my gateway in here. So in this case, 10.0.1.10. And the way the routing works is you have your system routes and your user-defined routes, and they're merged together to create the routing table. So the most specific route will always take precedent, but where I create routes the same, then my user-defined routes will take precedent because I've obviously deliberately created something to override the system routes. So now, you know, with this in place, I can do full micro-segmentation. So even if Web 1 wants to talk to Web 2, it has to go via the VSEC gateway. So what I'd probably do is add another route here to make sure. For example, with my backend subnet here, I've got my 10.0.3.0 network. It's now going via the virtual network. So server 1 wants to talk to server 2, it'll talk directly. I may wish to leave microsegmentation on for my web servers because they should never talk to each other anyway. So if one wants to talk to the other one, then that would suggest there's a problem and maybe one's been breached or something. And at that point, I'd want them to generate alerts and look at why that's happening. It also means I can quickly isolate by just changing the routing or changing the policy. Now I can completely isolate a machine from everything else, particularly when the micro-segmentation is in place. I could just stop it talking to anything else. So I know a machine's been compromised, for example, I can immediately just isolate it from everything apart from my remediation servers. And I can have up to sort of 400 different routes in here, so you can be very, very complex if you want to. So in terms of a typical deployment we see in Azure, and this is the Microsoft recommended method as well, we'll create again, in a similar way to AWS, we still create this services or transit VNet, and then I'll deploy my machines in separate networks below. In this case, though, I'll just use VNet peering to peer the two together. But so my app VNet, my first one is peered with the services VNet. My second is peered with the services VNet, but they don't peer with each other. So again, it adds another layer of security in that, you know, if worst case a machine gets compromised in one of my VNets, as well as I can still do the micro-segmentation within this as well. I can still force all the traffic up to the VSEC, but it doesn't even have visibility of the other VNets. And the only way it can ever route between them is to go to the VSEC gateway and back down. So it gives it an additional layer of security. But I can still, even within those additional VNets here, I can still apply my user-defined routes like I did in the previous slide, and decide exactly what traffic goes directly, what goes through the gateways. Because if I'm running things like database synchronization, I probably don't want all that traffic going through my VSEC gateway because it's going to place an unnecessary load on the machine. So I can create exclusions and do that quite simply. So I can be very specific in what I want to do. So when you're planning your deployment, I guess this is one of the first things: is what regions do you want to use? And there are ways as well. If you've got multi-region and multi-zones, you can use multi-region. Azure, for example, has traffic managers. So if I've deployed into UK South and UK West, I can use a traffic manager to have both sites active at the same time, because that's a service that sits above my infrastructure. Again, similarly with AWS, I could use elastic load balancers, which can sit outside my VPC and route traffic between two zones. So you can create geographically spread HA solutions. But that's the key thing: what availability do you require? Because if you've only got a single web server, do you really want to go down having, there's no real benefit then in having multiple regions, multiple zones. I mean, Azure, for example, on a single machine will give you a 99.9% SLA anyway. So again, similar to you would do with your physical deployments, where do you want to deploy? Where it's going to be close to your customers? And what level of availabilities do you need? Do you need active across regions? Do you need is active passive okay? You're just going to have one as a DR site, and from there you can start to then sort of fill in the blanks with where do I put my security? How does that scale, and so on. So now moving on to VSEC and how we address the problems within secure the cloud environments. So we have the VSEC gateway. We have the two products within the VSEC family. We have the VSEC gateway and the VSEC controller. So the VSEC gateway, first of all, is just a virtual appliance, the same as our physical on-prem appliances. So we have all the controls and prevention technologies that we would have in our physical equipment. So IPS, threat emulation, threat extraction, the 0-day sandboxing. We've got application control, URL filtering, antivirus, anti-bot, and so on. So all the blades that we would have on the physical machines, we do on our virtual machines, and we can offer the same level of protection with the VSEC gateway. The VSEC controller is a plug-in to Smart Center, our management server. So in the case of public cloud, it's a free plugin on the latest version, 80.10. It's just a standard part of the management server. But what that does is allows us to query the API of the cloud interfaces and start to use objects, and also then allows us to create dynamic policies using the objects from the clouds. And I'll give you an example of that in a second. In terms of the overall portfolio, as well as the public clouds, we do Ali Cloud as well, but not so much in Europe. We also support VMware NSX, Cisco ACI, OpenStack for private cloud, for on-prem. Obviously, we've already talked about Amazon, AWS, Azure, GCP, and Ali Cloud for public clouds. Nuage Networks generally we integrate with, and that's normally used in conjunction with OpenStack, again to enable customers to do micro-segmentation within OpenStack. OpenStack on its own is just layer 2, layer 3. So New Edge Networks allows OpenStack to do microsegmentation as well. And the key thing really here is whether you've got physical gateways, virtual gateways in the different public clouds, private clouds, you can manage everything from the Checkpoint Smart Center. And this could be your physical on-site appliance. It could also sit in Azure. It could sit in AWS. As long as it has access to the gateways that it's managing, it can, it could be physical, it could be virtual. It doesn't really matter. But that gives you that unified management. You can apply a consistent policy across all the environments, and also, very importantly, unified visibility. So all the logging and alerting and all that information is coming back to Smart Center as well. So you have a central place to actually audit and see what's actually going on in your environment to keep that visibility. So moving back to the VSEC controller, what it allows us to do is to create these application-aware policies, as we call them. So you'll see in this example policy we've got a mixture of public and private cloud objects. So rule 3 is a vCenter object from VMware vCenter. So that's just a VM name talking to an NSX security group. I've got rule 5 is I'm using a tag saying anything that has the tag internet allowed is would be allowed out to the internet, for example. Having created these objects, what we do is the VSEC controller is holding every 30 seconds to look for changes. So I've created my policy, I push my policy. If I had another machine to my NSX security group, for example, that IP would be pushed to the gateway within that 30-second polling period and take effect. So you wouldn't have to go on and raise a change request, create the object, new object, push the policy. It would just happen for you. Similarly for public cloud, if I'm using tags, if I bring up a new machine that I want to have internet access, I just apply the tag and it will match the policy, and that object, the object will be updated. So, and you can control within obviously in the case of public cloud, if you can control which users are allowed to create tags, because obviously that does impact the security. So again, you can keep, lock that down to certain users, or certain types of tags can only be created by certain users. So the first thing we use here is we've introduced these new data center objects. So in this example, I'm using one just to connect to Azure, and I'm using an Active Directory service principal to authenticate. And you can see there's a test connection button, so I can click on the button, make sure it's connected. And I just need read-only access here, because all I want to do is read objects that exist in Azure. So here's a policy with a couple of objects I've used from Azure. So in the first one, I've got a Windows machine called Win 2012, and you can see the IP address is retrieved automatically by the VSEC controller. Now, if that machine's IP changed, we pick that up within the 30-second polling period, and that IP would then be pushed out to the gateway. And this can be sent to your VSEC gateways. You can also use it for your physical gateways as well. So again, we can, because this is all controlled by the management server, it's really just, we're just dealing with IP addresses. We're still a network device. So we can push these to use these objects and update physical gateways. So the firewall that sits in front of your express route or direct connect, in the case of AWS thing, you can have a rule that just defines the whole VPC or VNets that you're using and say only allow access to these ranges from these sources and so on. So it allows you to be very flexible and very dynamic. And then in the second rule here, I've allowed it to talk to a machine that's got a tag of type equals web server, and they're just a name value pair. It can be anything. It doesn't really matter. But again, we'll be polling for anything that matches this tag. So if I deploy another machine and give it the same tag, you'd see multiple IPs in there. And again, within 30 seconds, you'd have access. If I removed the tag, so there's no machines with the tag anymore, then it would just disable that object, and the rule would no longer work. So we're not going to create like an any rule or anything like that. If it goes to null and there's nothing there anymore, then it disables the object. The whole rule becomes ineffective. We don't delete the rule or anything, because you might want to shut a machine down, or you re-enable that rule later, so it stays valid, but it will just be disabled if there's nothing that matches it. So in terms of architecture options, and I'm just I'll give an example of Azure here, but the deployment methods are the same for AWS as well and for Google Cloud. So I can deploy a single gateway, again, in a similar method to we would on-prem, so we can advertise public IPs, we can for the websites, we can do the inbound and outbound protection, including the full 0-day protection. And again, within Azure, I can set, either just check between the subnets or even do full micro-segmentation. We can do clusters. The main difference in clusters in the cloud platforms is that they can only be active passive. Is I guess the key thing, because the cloud platforms don't support multicast. So normally we'd take full control of failover and the event, and load balancing and so on. We can only have we can only deploy active passive, because one machine will route to the IP of one of the machines. And that's how it has to work. And then on the failover, the other key difference is the failover is an API call, because we don't control the underlying IPs associated with the VM. It's controlled by AWS or Azure. So when we detect a failover, we make an API call. So we need an API account to do it. So it is architecturally slightly different, but functionality-wise, it's the same. The third option is the auto scale, which I did mention earlier, and this is. We say it supports HTTP and HTTPS only. Really, it can support protocols that can cope with this type of environment. Because if I pull a machine when I'm scaling down, if I delete a machine and my session's going through that, if it's web, it doesn't matter. It would just request the objects. If it was an RDP session, it would die. You'd have to reestablish it. So the way it works, we'd start with, for example, 2 servers and a limit of maybe 10 servers for our VSEC gateways, and Azure or AWS is monitoring the performance of these gateways, and when they hit the threshold, the default is 80%. It automatically deploys a 3rd machine, a 4th machine, and so on, scales up to cope with the load. And what will happen is the management server is monitoring for these machines. We're actually monitoring for tags in a similar way as we do for the policy, but just so we can pick up new VSEC instances being spun up. We'll see the tag. We'll push the policy to it. Once the policy is installed, it'll be added to the group. When the peak's over, and again, it'll be purely based on performance levels of the machine. So when it drops to, say, 40% utilization, we can then spin that machine down and spin down back to, eventually whatever the minimum level is. So if everything peaks over, it's going back to normal traffic. We might have scaled up to 10. We'll just automatically scale back down to 2. And you'd assume as well that the web interface and back-end environment is also going to scale up to cope with those loads. But it gives us that elasticity to be able to cope with peaks and troughs. And typically in these environments, people would choose pay-as-you-go, because you potentially want to go to 10, 20 gateways, but you're only going to use them 3 or 4 times a year. So it doesn't make sense. Most of the, I'm not really going to go into licensing much in this. We offer the bring your own license, the normal method. In most scenarios, probably 92, 93% of cases, that's what people buy. But occasionally like these, we can offer pay as you go as well, where it makes financial sense. So the steps to securing your environment in the cloud is, first thing is control the perimeter. And use advanced threat protection. So you deploy your next gen gateway at the perimeter, route the traffic through it. So you can now start blocking. You can now start protecting the applications. Most attacks are going to be layer 4 to layer 7, and the cloud security. The security groups are only working up to layer 4, just source address, destination address, port number. They're not even protocol aware. So if I'm allowing port 80, I hope it was web, but it could be SSH. It could be anything. So the first thing to do is route the traffic through next-gen gateway with the IPS and 0-day protection. So your machines, when you're first deploying, at least they're not going to get infected from the outside world. They're completely protected. The next step is to secure the cloud from the inside. So you want to start segmenting things off. The level of segmentation, as you've seen from the previous slide, differs really between AWS and Azure. In Azure, I can do full micro-segmentation. In AWS, I can do it with VSEC today down to the subnet level or VPC level, but then I could also use security groups to extend that. So I can hopefully stop the prevent the lateral spread of threats within the environment. And thirdly, consistent security policy. So having deployed a next-gen firewall within the cloud, I can apply the same policies that I'm using and the same controls that I'm using to my on-premise gateways. So I can have a single pane of glass view, the same types of policy, the same levels of control, and central visibility of my platform. So again, you're not having to train your security. You don't have to learn the ins and outs of security groups and different solutions. They can do everything from one pane of glass, and all the logs and all the information, more importantly, back to the same place, so you have total visibility. Step 4, and I think most of the customers I deal with aren't kind of at this point yet, but it's probably the way that they want to go in the future, is to start to automate. So you can auto provision. The R80.10, our latest version of the management server, has an API, so I can automatically use orchestration tools to create objects, to push policy, and so on. So this is the way that people will probably go longer term. But yeah, at the moment, most customers are not that advanced yet. So don't worry if you're not there. Most people aren't there. But some of the customers we have will automatically deploy whole environments, bring them up for a day, test them, shut them down, and then use the same templates to deploy the production environment, knowing that what they tested will be exactly the same in terms of spec, versions, and everything as the production, which is, again, is something that probably is difficult to do with physical kit on premise. So why not use the built-in security? So the platforms come with their own security. The issues are the cloud-native security, as I said earlier, works just up to layer 4. So you can define, source IP, destination IP, port number. They're not protocol aware. It's just a port number. So they as I said, an example, if I'm allowing port 80 out, if I run an SSH server outside on port 80, I could SSH to that. It has no concept of what the protocol is. There's no single view. You can get logs. It doesn't log everything, but you can get logs. And most importantly, there's no zero-day protection. It is just network layer. This is effectively access lists, state with state for the machines. On the network level, there isn't. It's just access lists. So it is kind of 20-year-old technology. It's not really suitable for modern security. Most of the attacks are going to happen above layer 4. If that's all you can protect to, then you're going to miss most attacks. Brute force attacks, there's probably anything you can kind of stop. But again, I think as Shona said, the cloud vendors tend to be fairly open about this. And I've given a link here to Microsoft best practices on what they say. Azure Network Security Appliances can deliver significantly enhanced levels of security over what is provided by the network level controls. So their NSGs, their built-in controls, because it can't do any of the advanced firewalling, intrusion prevention, and zero-day protection, and so on. So again, they recommend that you work with one of the partners, such as Checkpoint, to give you the protection that you'd expect in a sort of modern data center. So why VSEC as opposed to somebody else's firewall? Trusted policy delegation. We again, under 80.10 now, we can have multiple administrators. We can lock down to just sections of the policy. So as you start to automate things, you might have an orchestration tool. You can give it access just to part of the policy. So by sharing administration and allowing people to automate things, we don't necessarily have to give them access to the whole policy, just sections of the policy. So you can limit what they're able to do. And again, that's quite unique within the industry. Simultaneous updates. When we moved to 80.10, we introduced a sort of full database system to control the objects. So if I'm logged on and changing an object or changing a rule, that's locked to stop anyone else doing it. So if we're going to allow multiple administrators, and particularly automation tools, we've got to make sure we don't have two people trying to write to the object at the same time. So to lock it until I've published my changes, orchestration tools can just retry until it becomes available, and then they can apply the updates. And then dynamic changes. So again, having the VSEC controller, having the ability to learn as things change within the environment, again, is key. And again, we can within 30 seconds, we can pick up these changes, and we can publish them on the VSEC gateways, but also on the, we can update them on the physical gateways as well. So we can be very dynamic in how we work, and also using the API, we can dynamically change things via the API in response to events and things like that. So it makes it a lot more flexible. So in summary, we can extend the advanced security that customers are used to for their on-premise environments to the hybrid cloud, to public and private cloud. We can introduce security automation. So with the API on the management server and with the VSEC controller picking up those dynamic changes, we can automate the security and save a lot of work for the security admins. And we still retain this unified security control and visibility. So one management platform for all the environments, everything back to a single place, which again, a lot of our competitors don't do. You need multiple platforms for different environments. So one platform to understand and master, and one place for that visibility of all the events that are happening within your environment. So thank you. That's the end of the slide. So we can go through any questions that everyone has now.
Okay, thanks, Andy. I'd just like to invite the audience to pose any questions via the chat or the questions box, and I'll pose them to Andy over the next few minutes. So I have my first question here. That was quick, fab. Questions from the audience, Andy. Are there any plans to integrate with Oracle Cloud?
Yes. So we currently do have some customers testing Oracle Cloud. So we have an early adoption program at the moment. We have some customers in there. I don't know timescales for when it will become generally available. So because we support Hyper-V, KVM, and ESX as hypervisors, most of the cloud environments are going to be using one of those. So to deploy the gateway into the environment isn't generally that difficult. And normally we'll do a two-stage, which is what we've done with Google. We'll deploy the gateways in to work in the cloud, and then we'll add the VSEC controller, because that's obviously a bit more complex. We have to integrate with the APIs. So with Google, we supported Google earlier this year, and the VSEC controller is now going through. Again, that's on early adoption, so it's available for customers that want to test it, but it'll go GA probably the end of this year. Oracle Cloud, we're going through the EA phase of testing the gateways, and then I guess at some point next year we'll also include the VSEC controller to start using the objects dynamically as well within the policy.
Thank you. Oh, good news, work in progress. So are there any other questions from the audience? As everyone sort of thinks of anything or takes time to type, I'll just like to thank everyone for their time today in attending. Really appreciate you taking time from your busy schedules to listen to such sessions, and hope that you found it really useful. Thanks Andy as well for his detailed presentations. Apologies for the brief audio issues in the middle, which hopefully we resolve for you. And also have the session recorded. You'll receive recordings, so you can obviously share that within the wider business. I haven't got any other questions at this time, so what I'll do is just wrap up. Thank you for your time. And we will send the session out post-webinar, and please do take 2 seconds to fill in the feedback form at the end. Thanks everyone, and good morning.
Thank you.